Okay, here we are again, and then we're going to continue now with part 2, the raster operations. So this is where we were with part 1. Actually, by the way, don't forget to save your project very often, because if it crashes, you can always get it back in the position where you were. The data is saved in its own files, so you can always, even if you didn't save the project, you can always load the data again. You say if you saved it to files. Okay, this is stuff that we use for the vector part 1. So I'm actually going to leave it there and turn on the raster. So this is where we start. CLC, Corin Land Cover 2018 from Adam, Amsterdam, it means. So this actually is a very large data set that I collected from European Environmental Agency, and I've clipped it to Amsterdam. And I've also added the legend, so you can actually read what all the different colors look like. So continuous urban fabric, discontinuous urban fabric, industrial, road, port areas, airports. The idea here for the first step, similar as in part 1, that you understand the legend. I'm going to do it very fast. You're not supposed to do it so fast. You're supposed to look at the legend carefully, understand the data, see here the resolution. So the data is actually made of squares. This is a raster data set. And now we're going to use this data set to intuitively draw the urban agglomeration border. Okay, and just like in part 1, the first thing we should do is create a new shapefile, and we call it herb draw ras. Okay. Now it's asking you, you will have to transform. You say okay, so because you want the destination CRS to be 28992, I say okay. And oh, I made a mistake. As you can see, I made it into points. So this is not what we want. Good. So we can just remove it. Remove this layer. Okay. And let's do it again. New shapefile here. New shapefile layer. Not a point, but a polygon. Actually, now I see why that popped up here. I also want it to be our 28992 projection, because this is good for the Netherlands. And let's do it again. Urban herb draw ras. It probably is gonna ask if I want to overwrite. Okay. Well, no, maybe I change it slightly. Urban draw ras is empty again, and let's start editing it with this button here, and let's start drawing our polygon. So I imagine that you've read and you understand the different classes. I'm gonna start here, and then a bit faster now. Here not Amsterdam suppose. Amstelveen, leave it out. Now those is included. I want this part. North, this part also. And here also. And at the end, I right click and I close the polygon and new ID. Okay. And this is what the new polygon looks like. And you can actually turn on the previous one you made, and so you can actually observe or discuss. You can use this overlay as a screenshot to discuss how similar or different they are. So that's what is expected in the assignment. Okay, let's continue. Yeah, so let me stop, save the edits and stop editing. And we're gonna reclassify this into just urban and non-urban. So the easiest is just to come here and say reclassify. And it's interesting to see there's many different tools that seem to do the same thing. There's raster analysis, reclassify by layer, and reclassify by table. And there's also here from Saga tools, reclassify values, reclassify values simple. My experience is that reclassify by table is the nicest one, the most complete one. So, and if this doesn't work for you, you can try these Saga tools. And I know that for some Mac users, they've had difficulties with reclassify by table. And I recommend reclassify value simple. That should work also for the Macs. I'm going to use reclassify by. Yeah, so we're going to use reclassify by table. And what we're going to reclassify is our Corinne land cover map. And this is important. So which values do we want to reclassify? We're going to have to fill in a table. We're going to say add rows and say what is the minimum value, the maximum value, what is the new value. So here I have to put in the ranges of the values that I consider to be urban and give them 1, and the ranges of the values I consider not urban, and I'm going to give them a 0. Or if you leave them out, you can use this checkbox, use no data when no range values match. So whatever is non-urban becomes no data if it's not part of these ranges. So in order to know which ranges we need to use, I can right click here and say properties. And I have here the values. So the raster data only has values, but we've associated labels with it, so we can recognize it. So 111 is code for urban continuous fabric. 112 is code for discontinuous urban fabric. Then 121 is industrial commercial units. 122 road and rail networks. So because I consider road and rail networks not to be part of the urban agglomeration, well, they are, but they also, you can also find them outside. So I'm not going to include that, and I'm going to try to include port areas. I'm going to try to include it again. So this is going to be for, so you should go through the whole list and see what is urban, and let's try to make all the urbans to be 1 and the rest stays no data. It's easier for now. Okay, let's put in this one. So range is from 111 till 121, list out, and then this back in. Cancel. Like so, you have different types of way of doing this. So minimum value greater than or equal to our value, and then smaller than the max. And I think the easiest is indeed, let's use this one. So it's bigger than a certain value and smaller than another one. If I remember correctly, it tends to be bigger than 111 and it should be smaller than 121, and then 122 will exclude. We go back to our table. So bigger than 110, so that 111 is included. 121, 122 actually we include, and this is urban. See, and then add another row, and then 122 bigger than 123 we don't want to include, so actually 123 all the way to 124 for the ports, and this is also 1. And just continue throughout the whole list. Okay, throughout the whole list of values that you have here. So in this case, 122 was excluded, 123 was included. Airports, oh, because we've just included also airport in previous, let's include that one also. Mineral not. Okay, 122, 123, 124, and 122 should be excluded. Okay. No, I changed my symbology. That was a mistake. Yes. Because I changed the symbology. Now I see how easy it is that you can lose your symbology. I pressed OK instead of cancel. So if this happens to you, so now it thinks it's a continuous instead of unique values, since it's a continuous field. I'm going to load my symbology again, and I'm going to share this file with you in case this also happens to you. It's the legend. I prepared it nicely for you. Here we have it back. Apply. Okay. So where were we? Oh yes, we were changing this. So what I want to do, this is back to 1. So this one we said it goes all the way until 5. Okay. I remember correctly. No, actually it's 1 to 2 we want to get out. 2 to 3 into 4 we want to keep. Cancel, don't forget. This one we want to get out. So this has to be maximum 1, and this would be 1 to 2 because it's greater than, so it does not include 1 to 2 all the way to 1 to 4. Yes. Okay. So this is important. So if you want to, everything that's not urban, we want to use no data for it. And the reclassified raster, we're going to give it save to file. I'm going to say CLC reclass. Okay, run. Okay, close. Brilliant. Now we have only values of 1, and the no data is not showing, but this is then our reclassified raster, exactly what we wanted. Okay, and now the next step is that we want to close some of these gaps and to have one continuous urban agglomeration. So this is the park, this is another park, and we want to close them. And maybe this we also want to close. So we can again measure the distance, 400. So close. So I would definitely want to close this gap here. So at least 400 I will need to have, or 200 on each side, let's say. And you do that by buffering. So if you type in buffer, there's many different tools for buffer. In this case, we need a raster buffer. So in my case, when I created this assignment, I was using 3.10, QGIS version 3.10, and the different raster buffers, the Saga raster buffer, did not work for me. Also the GDAL, sorry, this is vector buffer raster. So I had this raster buffer, and it did not work for me. What did work for me was this grass raster buffer. So you can try yourself with your own version of QGIS. Maybe you have a newer version. Maybe on a Mac it works. You can just try with the raster buffer. But for me it didn't work, so I'm going to use this grass. And I say R buffer. It says, oh, I cannot run this. You don't have grass installed, because grass is a kind of an external library. So you have to start with grass, QGIS with grass. So what I recommend is that you save your file for now, and now we close it. And now what we're going to do, we're going to start QGIS, but we don't start, you start QGIS desktop 3.10 with grass. You see here, and there we go. Takes a while. There we are. So it looks exactly the same. The only difference is that grass is available to us now, we hope. Let's start with the one that we were busy with. This is the last one. Exactly where we were. So we're going to do it again here. Buffer raster. Not buffer raster. This one. And great. Now these grass tools are also available to us. So what do we want to buffer? We want to buffer our reclass and distance zones. You can do multiple buffers. So I'm only interested in a buffer. I think I said 400 meters. Now this is important. If you created a raster file with ones as urban and zeros as non-urban, you want to ignore the zeros, so treat them as null. In my case, I only have ones for urban and no data for the rest, so it doesn't make a difference. But this is where you choose that. And then everything else, I think you can leave it as a default. And we're gonna save to a file, and we're gonna say CLC urban 400. I say save, and I'll say run. There's some warnings here. Keeps on busy, so it'll buffer out. Okay, this is great. So now we see it's very interesting, this output. Let's observe it carefully. So it gives us in purple the original value of our urban. In yellow with value 2, it gives us the extended buffered area, and the rest is still no data. But I see that we have a lot of data here, but we don't need it. We just want it to be urban, non-urban again. So what we're going to do, we're going to reclassify again. Reclassify by table, and we're going to put in our CLC urban 400, and we're going to say that at a row, everything between 1 and 2, but now I'm going to choose becomes 1 urban. Okay, but I say 1 and 2, so it needs to be this one. 1 greater or equal. And the rest I want it to become no data, and I reclassify it here again, and I'm going to say CLC urb 400 reclass. Save and run. There we go. Close. I can remove this one. I don't need it anymore. And now we have our reclassified value. But remember, it created artificially big borders. This is how it looked like. This is much bigger, 400 meters bigger. So we want to move back to the original urban borders. Yeah. So, and again, to shrink it back to the original borders, for me, I tried different tools, like a buffer with negative values, like we did before, and it should work, but for me, it didn't. The only tool that worked for me is called the shrink and expand. It's a Saga tool, like I mentioned before, shrink and expand. So if I choose this tool, and here indeed I have our urban 400 reclass, and I want to shrink it, and the search mode should be a circle, and the radius. Now this is interesting. So it's not based on geographical units anymore. It's based on cells. So how many cells do we have? So we just enlarge it 400 meters, and we know that each cell is 100 meters, 100 by 100 meters. So we need to shrink it by 4 cells. Yeah. And for method, it actually looks in the surrounding cells, and because we want to shrink it, we choose min. So the minimum value that it finds. So if it finds like a no data, a very small value, it will keep that one. And that's what we want it to do. I think this is it. And again, save to a file. And now we call it CLC shrink 400. Save. And again, interesting that because it's a Saga tool, it saves not as a TIFF file, but it saves as SDAT file, so a Saga data file. Doesn't matter, it's still a raster, but it's just a different format. Now run. We wait. Seems to be complete. Close. Doesn't look very different because maybe it's still on the under it. Yes, so we can really see the difference. This was the 400 buffer minus 400. We see now a very contiguous urban area, and we got rid of some of the holes that we had before from this one. So this is what we had. You can see now that it nicely follows the same borders, but things like breaks and holes that were in between, they've now been removed. It's interesting that some areas became now contiguous where they were not. So this has to do with with a threshold. So what do you consider to be a continuous area or not? So you have to be aware of that. So on the buffer that you choose. Okay, so the next step is that I still have many different regions. We actually just want the big one. Let me turn on our final one. So we have this. They're all different regions. So we just want to keep one or several big regions. And so we need to identify each one of these regions separately. But it's a raster, it doesn't know how to do that. If we look at the identifier, it only has value 1. So all the cells have the same value of 1 or no data, you see? So in that case, we need a tool that identifies cells close by each other. And luckily there's a tool for that, from the raster. So if you don't have, if you're not running your QGIS with raster, now it's time to save it, close it, and open the QGIS with raster. And it's called raster clump. And a clump is exactly that, is a chunk together. So we're gonna put in our shrink data. And this is important. You have to decide if you want to clump diagonal cells or not. So have a look at the document that of the guidelines. Think about what you want to do here. I'm not going to click it, but think about what you want to do and explain why in the questions. And an output, I'm going to save it to file, and I'm going to call it urban clumps. Save, and I'm going to say run. It says I need a title for the output raster map. Okay, so we need, it's not optional, but it needs a title. We're going to call it clumps. And now run. Close. Yes. So now we can identify each one of the different clumps. I actually made, let's have a look, 41 different clumps. But we are not ready yet. We don't know which ones are bigger or smaller. Actually, we do know. You can see them, but we don't exactly know if it was not so clear, or we don't know actually which. If I click here, 34. So we kind of knew, so we could use it. But imagine we want to measure how big is our clumps. There's also a tool for that. It's called the raster layer unique values report. So if I run this one and I say the urban clumps, and then I want to save it as temporary file, save to a file, and I'll call it a clump report. Save. But this is important for me. Unique values table. And I experienced that you can leave this as save it to a temporary layer. So we'll create a temporary layer, shapefile layer in our table of contents. Let's run it now. Here we go. We have the report here. We can click on it, and we can see the report. So each value has so many pixels and has a certain area. But it also creates here a table. It's temporary because you see the memory. It's only in memory, the memory icon. But I can right click on it and say open attribute table. There we go. We have for each value of the clumps, we have the count, and we have the square meters. And I want to think about it. Okay, they are related. 147 cells is very similar to the square meters. Think about this relationship yourself. What does it mean? Can you also think about why is it not exactly the same? We can discuss it, but it's interesting. Okay, now we can sort it. And of course, there we go. We have a very large number here. Let's keep only this one. So if we want to keep only this one, this is the value, 34. Now we know it. We can, if we want to keep more, these were the other ones, but let's just keep 34. Then we go back to our old friend, reclassify by table, and we say what we want to reclassify our clumps, and we want a fixed table. We want add a row, so everything between 34 until 34 becomes 1. Everything else we don't care, becomes no data, but I think it's from 34 to 34. Let's make sure it's correct, this one. And the rest becomes no data. Save it to a new file, and I'm gonna call it urban glow. Save and run. And that's it. We've finalized it. So according to our process, this will be the urban agglomeration of Amsterdam. So I want you to think how, if you really wanted to close a bit more of the holes, or if you didn't want to have these connections, how would you solve it? That's the question for the tutorial. Thank you for watching, and I'll see you in class.